like a practice today. We are going to work on using the Delaunay algorithm to create this kind of a jagged like a form using our previous like a loft like a surface that we have. So let's try to use this time from the basically paneling. We are going to use the or triangular panel. So we are going to use the triangular panel, which comes from the lunchbox. If you recall that, it was a part of the paneling, and this time I'm going to use the triangular panel. What that requires is basically requires us to have a surface, and also it's the number of the U and V, the division. So if I look at, it's like creating a 10 by 10 UV and then create that triangulation. Now, if you look at the form itself, you see that what I'm looking for right now is like there is a peak in the middle of this triangulation somewhere. So I need probably finding this center for those triangle first before going anywhere in my algorithm. So I'm going to use the area and then using the panel itself to find the center point. And I know that this center point doesn't necessarily are on the surface, and we want to use that like a UV later on for getting the normal value of the surface. So what I would do is that I'm going to use the surface point, so the closest points to surface. And then use the series of the area, the center, to the point, and the surface itself would be the surface that I have here. I'm going to connect it here. So now I have basically those like an area center point and also the point on the surface itself. Now what you can do is that we can use the evaluate surface, right? And by the evaluating surface, I have my surface itself, right? But this time, the evaluation that I'm going to use is not going to be the evaluation from the loft itself. I'm going to use these panels. And I'm going to use the UV of these points itself. So I'm going to bring those points here and then connect them there to this. So what I would get out of it is like a series of like a plane and also the normal value. That's what I'm mostly interested on. I know that by the fact, because this surface normal can be positive or negative, and I want them all to be up, I need to use the absolute value to just make sure that all the normal value that I get is going to be positive. So I'm going to use the absolute and then connecting the normal vector data into that. So far everything looks good. I need to basically I need to move those objects. So I'm going to use move. And for the move, I'm going to connect the points that I got from the surface, like the closest point from the surface, and the vector data will be this. Let me just turn off all these things here for now, because we don't need them. And we can see what we got so far. Actually, we need the triangle surface to see. So I got these value that you see. It's like above the center point. And now what we need to do is that we need to deconstruct this panel because we need some of those vertices to create that new triangle. So I'm going to go back here. I'm going to use deconstruct rep, and then getting those panel. Let me just delete this for now. Using that, so basically getting the points, endpoints here. And now what I need to do is that I'm going to merge them all together. I'm going to merge, and I have one geometry here, which if you look at it, the data is 110. Here I have a series of vertex, but they are in a category of like it's grouped in the tree. So what I would do is that first of all I simplify that, and keep that as a graph, and then the data I got here, I'm going to graph it as well. Now I can connect these two together. So basically that's going to be my new merge data that I want. Now I have this part, and let's bring the Delaunay mesh. Now we know that we have the series of points. We have the 4 points there. Here I'm going to use the plane normal. So with the plane normal, I have the origin, which is the origin coming from this point, and then this part, which is the z vector data, and the z vector data is coming from this absolute value that I have. So now that I define this plane, a series of plane, I can just connect them here to this part. But before I'm connecting them, I'm just making sure that I graph them. So basically, this data will be on the like a graphed format when it's connected here. And then let's take a look, see what I missed. And then turn the preview off. Data I get here is correct. Oh, the merge is not correct. I think that's the reason is that this data is simplified, this data is not simplified. So I have to simplify that data as well. So let's see the merge here and then here. Type of data I get is 0, 1. Here I got 0, graphed it. It's not using the graph here. Okay, great. Now, if you look at the outcome data, you see that the outcome data is like 4 points in each of those graphs. So basically, I simplify that. If you recall, when we not simplifying the data, we got a different format for the item, and then they are not combining correctly. So if I look back in my drawing, you see that I create that like a jagged area, which is the center point of these pieces. So then I can just use the preview to see custom preview, and then connecting that surfaces here, and then turn everything else off. So then we can get a better look of the surface that we created.